So first, we're going to cover rapid per VLAN spanning tree. This is the default STP mode within NXOS and on the Nexus 7000 switches. As the name implies in rapid PVST, each VLAN elects a single root bridge, and all other devices determine the lowest cost path to the root bridge. With rapid PVST topology, changes are isolated to that particular VLAN. One additional characteristic worth noting is that 802.1w is backwards compatible with standard per VLAN spanning tree for migration or interoperability purposes. So to illustrate rapid PVST from a configuration point of view, I'm going to configure it here, and so the first step would be to go into configuration mode. Next, I'm going to set the spanning tree mode on the system to rapid PVST. Once that's set, I can define priorities for individual VLANs. So I've created a couple of VLANs on the system, VLAN 10 and VLAN 20. So I want each of those VLANs to have a different priority. So we're going to give VLAN 10 a lower priority on this system because I want this system to be the root bridge. So I'm going to say spanning tree VLAN 10 priority 4096. Right? Now I've created another VLAN, and that VLAN is VLAN 20. So I have another system, N7K2, that I've defined VLAN 20 already as priority 4096 on. I don't want this switch to be the root bridge for that particular VLAN. So I'm going to define this priority as 8192. Right? Now you'll notice these increments are in increments of 4K, and that's done because spanning tree adds the VLAN ID to the individual priority. So in this case, VLAN 10's actual priority on the system would be 5006 as we add 10 to 4096. So thus the hop in increments of 4K as we go along. Next, we're going to cover multiple spanning tree, or MST, or 802.1s. In large layer 2 environments, MST can be used to provide a much simpler configuration with lower control plane overhead than rapid PVST. When MST is leveraged, VLANs with similar topologies share a single spanning tree instance. This lowers the control plane load because we don't have to track control plane for every individual VLAN like we would with rapid PVST. MST instances with identical names, revision numbers, and VLAN mappings create a construct called an MST region. For further simplification of complex layer 2 domains, each MST region is presented to the network as a single bridge. It is also worth noting that MST is backwards compatible with rapid PVST from a migration standpoint. So now let's look at some of the configuration elements for MST. So I'm going to start by going into configuration mode. As we did with rapid PVST, I can enable MST on the system globally by typing in the command spanning tree mode MST. This enables the switch to run in MST mode. Now we have to do some MST specific creation. So we're going to create that by going into spanning tree MST configuration, and this is going to bring us into a sub-stanza for the MST configuration, or our region. Now, I'm going to give this configuration region a name. We're going to call this AG1. Now, with MST, I can define multiple revisions. So I'm going to say that the revision for this particular configuration is 10. Now, real quick, we can show some of the pending MST configuration by typing the command show pending. This is going to give us some of the configuration options that are pending based upon what we're doing here. So as you can see here, we're setting our name. So I'm going to exit out of that. I'm going to go back into the MST configuration, and I'm going to create two instances inside of that. So first is instance 1. And I'm going to bind that to a VLAN that I've created on this system, VLAN 10. And then the second instance, I'm going to bind to my VLAN 20. So that concludes the configuration options for MST. Okay, so let's look at some of the options that I like to say we have available to us in our spanning tree toolkit. So first is BPDU guard. What BPDU guard does is shut down an interface if a BPDU is received on it. Generally, you would use BPDU guard on a server-facing interface in the data center, right? You would configure this on a port that you would not expect another bridge to be cabled on, and you would want to protect your entire STP domain. So we would configure BPDU guard again on a server-facing interface, most likely. Another feature is BPDU filter. Now, BPDU filter can be a little bit more complicated because it can operate in a couple different fashions. And essentially, the goal of BPDU filter is to prevent a port from sending or receiving BPDUs. BPDU filter is usually used with BPDU guard to prevent an inadvertent misconfiguration that could introduce loops in your environment. When BPDU guard is not enabled, BPDU filter still provides some safeguard against accidental misconfiguration. Here's where BPDU filter can get a little tricky. You can configure BPDU filter either globally or on a port-by-port basis, and it acts a little differently depending on how or where it's configured. So when configured globally, BPDU filter applies to all ports that are operational spanning tree type edge ports. Also, when BPDU filter is configured globally, a port initially sends a series of at least 10 BPDUs. This is done sort of as a safeguard. If the device receives the BPDUs, it returns to the initial port state and transitions through the listening and learning phases of STP. However, when BPDU filter is configured on a per port basis, it does not send out any BPDUs. So take caution when enabling BPDU filter, especially on a per port basis, as bridging loops may occur if BPDU filter is enabled on non-host facing interfaces. Last is bridge assurance. We'll get through some more on the next slide, but bridge assurance eliminates issues caused by a malfunctioning bridge. So from a configuration standpoint, let's get into that now. So let's look at the configuration options available to us for spanning tree BPDU guard and BPDU filter. So first, I'm going to go into configuration mode. Now, I'm only going to illustrate enabling BPDU guard and BPDU filter on an interface, but you can enable them globally, as we previously discussed. So I have a host on interface Ethernet 121, and I'm going to turn BPDU guard. So to enable that, I'm going to type the command spanning tree BPDU guard enable, and that enables BPDU guard on that particular interface. I also want to enable BPDU filter on this interface. So I can do that by typing spanning tree BPDU filter enable. That enables BPDU filter on this interface. We also talked a little bit about network ports. So I have another bridge connected to this switch on interface port channel 1. I can set this port as a network port by saying spanning tree port type network, right? This enables bridge assurance on this particular port. From a best practice standpoint, especially in a VPC environment, the only area in which we would enable port type network would be on the VPC peer link. In a VPC environment, it's not advisable to use bridge assurance for host-facing or other switch-facing VPC interfaces, except for the peer link. We'll talk more about that later in this lesson. So again, I can enable that for our particular port channel, and that enables bridge assurance on interface port channel 1. So now let's talk about a couple other options available to us in our spanning tree toolkit. The first is LoopGuard, and LoopGuard prevents any alternative or root ports from becoming designated ports. The second is RootGuard, and it protects the root placement in the bridging domain. It protects a port from being a root port on a particular system. Let's look at the configuration options for both LoopGuard and RootGuard. So first, I'm going to start off by going into configuration mode. Now, I'm going to enable LoopGuard on interface Ethernet 1.2. I'm going to do that with the command spanning tree guard loop. This is going to enable LoopGuard on that interface. Now, I have another switch connected on interface Ethernet 1.3. So I want to protect this switch right now and enable RootGuard on that particular interface. So I'm going to type the command spanning tree guard root. This is going to enable RootGuard on that particular port. Now we're going to cover spanning tree port types and use cases. So I covered a little bit about network ports in the previous example of bridge assurance. So we won't spend too much time talking about network ports, other than typically network ports define connections between two bridges. Again, in a VPC environment, the peer link is really the only connection on the switch that should be enabled as a port type network. Spanning tree normal ports remain unmodified and operate as standard bridge ports, right? These would be ports that typically you would connect from switch to switch in a VPC environment. Next, we'll talk about edge and edge trunk ports. These ports were previously known as PortFast in iOS, and edge ports transition immediately into a forwarding state, bypassing the listening and learning phases. This is a very important note that only non-bridging layer 2 devices should be configured as edge ports. If you configured an edge port and plugged a switch into it, you could create a loop in the network. So now let's look at some of the configuration options for spanning tree port types. In the previous configuration example, we already covered network ports. So with a normal port, we don't have to do any additional configuration. It's the default. Also, spanning tree port type normal is the default on an interface. And if you needed to restore it, for example, on interface 1.2, if I needed to restore that now to a spanning tree port type normal, I could with the command spanning tree port type normal. And that would revert to, again, default configuration. If I wanted to set this port as an edge port, I could do so by typing the command spanning tree port type edge. Right? So it gives us a nice warning there that, again, you should pay close attention to about enabling an edge port or a PortFast. So that would be if this port was a standard access port and not a trunk port. For virtualized hosts, let's say a host that has a number of VMs on it, sometimes it makes sense to trunk a number of VLANs down to the host. So there is an additional command to enable PortFast on a trunk port. And that command is spanning tree port type edge trunk. And that enables spanning tree port type edge and PortFast for a trunk port.